Alright, so we're starting with exponential, basics of exponential graphs. So let's start with the notes from the book. Right? An exponential function is something from a power, we call it base b, to raise to a power of x. Right? And then we have exponential growth and exponential decay. We'll deal with that later on. But what you saw right here in the yellow, this is what we call the parent function. Alright? Where b is what we call the base. The transformation of the parent function is a, the stretch, times the base b. Then we have our hk. Alright. H is the horizontal shift, k is the vertical shift, a is the stretch. Nothing has changed. This whole line has been the same thing since we've studied parabolas. Alright. And so I've got an example here. Alright. Oops, that's 3, that should be 3 to the x. The example below shows the parent function of 3x, it should be 3 to the x, it is then stretched by a2. Alright, so there's a stretch. Right, here's the base right there, 3 to the x. That's written properly. That is not. And then it has a stretch of a of 2. So now it's 2 to the 3x. There's your stretch. Alright, so what was red, the parent function, is now blue with that stretch. Alright, just a little bit higher. And then it shifts right 1 unit and up 4 units. So what was here is now shifted to the right 1 in the purple. All right? X minus 1 goes right 1 and 4 goes up. Now, this floor right here, this dotted line, the floor of an exponential is called the horizontal asymptote, right here in the green. It is the k value. The k value is 4, right here, 4 units. That's your k value. All right, it is the y value, k value, but it is the horizontal asymptote. That's brand new, and the horizontal asymptote is always the k value. Okay. The exponential function has a horizontal asymptote, and the horizontal asymptotes are the k value, which I just said. All right. Last thing are domains and ranges. The domain for all exponentials are all real numbers. That is negative infinity to positive. There is not one thing that you can't put, that you can't take an exponential to. Think of it this way. What number can you not square? You can square anything. So it's from negative infinity to positive infinity. The range, though, starts at the k value. Alright? It starts at the k value. This, 3 to the x plus 2, my k value is 2. So my horizontal asymptote is 2. That's the floor. And so it will never, ever, ever touch that. Alright? Think of a best thing would be like a rock skipping across the pond, just so it stays afloat. Alright? That's what you try to do. How far can you skip it? Alright, I know it touches, but theoretically you don't want it to. Notice it's a parenthesis, since it never touches, it's a parenthesis. Alright? And then if it's a negative, if your a is a negative, it reflects over the x-axis, then what was up is now down, and so it goes down, and thus the h value, or the k value, is still 2. All right, there it is right there. It's still the 2. All right, but because of this negative right here, it's going down, and we always say the smallest number first. That's the bottom of the whole, which would be negative infinity, and it stops at 2. All right. And so that's what we're doing here. So let's begin, and then we'll probably make 2 videos on this. First one says, given parent function, our parent function is 7x. All right, input the correct transformation of the parent function. It is plus 16, x plus 16. That's our h, and since it's plus, it's going left. All right, since it's plus, it's going left. So the graph 16 units to the left. All right. Nothing has changed, right? A positive h, it's left. If it's negative h, it's right. All right, it's opposite. This one, transformation, my base is 5. This one's minus 15. This is my k value. It is down 15 units. That's where the horizontal asymptote would be. It's down 15 units. So it shifts 15 units, not up, but down to 15. This one has them both. All right. There's my h, which is negative 11, and there's my k, which is negative 19. But this is x minus 11, not negative 11, like I said, x minus 11. So it shifts 11 units to the right. So here I am, 11 units to the right in the middle, and it shifts 19 units down. So it's 283. All right. And then this one is I'm going to graph this. I'm going to graph this on GeoGebra. So here we go. We are dealing with exponential. So I'm dealing with this f of x. This is for a future assignment, okay? All right. And my base is 5, okay? My base is 5. Man, don't worry about the a. I'm tossing that out. Don't worry about the a. Just go to use GeoGebra. GeoGebra is better software to use on this one, okay? Type in 5 is your base. So I'm going to type in my 5, caret key x, all right? Then we'll type in x minus h. And instead of making a slider of k, I'm going to just put in my 2. My 2 is the y-intercept. That's where it starts. So 5 is my base. Caret key puts it up above. X minus h. Arrow key over so it goes down. See how it's down? Plus, I think it was 2. I'll adjust if I need to. All right. And so now I just have my slider as my h right there. Okay, right there. So now I want to, let's see here, settings. I want to, oops, there we go. Put my slider in, 1, enter. All right. Let's just make this a k. If I make this a k, now, let's just start over. 5 caret x minus h plus k. There we go. Now I got to create this increment of 1. Okay, done. Close that out. And then my horizontal asymptote was 2. Y equals 2. Y equals is the horizontal asymptote. All right. So now raise your k to the 2. That's probably the easier way to do it. That's how I tend to do it. Raise your k to the 2. The horizontal asymptote was 2. Okay. Now I need to plot this point. All right. Now the parent function is this red function. How I know? It's because it goes through 0, 1. Your parent function always goes through the 0, 1. So plot the other point, minus 2, 3. Okay. So there it is right there. All right. I'm going to show it. You don't need to do this, but just so it makes sense to you. I don't care about call day. I want 2, 3. There's my 2, 3. And so what I want to do is take my h and slide it over to that. There it is. Now remember, your h has one. You want your h as an increment of 1. So hit the 3 dots. Okay, and that's your answer right there. There is our function 5dx minus 2 plus 2. Now, the question says, put in this number right here. So I'm going to type in 3.7 f of 3.7, and my answer is 17.4. Take it to the tens. All right. Do another one of these tomorrow in class too. All right, this one, put in the correct asymptote. Your asymptote is a horizontal, so it's one of these 3 right here. And it is, I told you your k value, so it is 17. So I got a horizontal asymptote at 17. That's this one right here, 427. You either know it or you don't, folks. All right, memorize. Horizontal asymptote is your k value. All right. And then this is another one. I don't know why there's 2 on here, but it's a asymptote. And this one, horizontal, it's going to be, because it's exponential, negative 19. So there it is right there, 766. All right. And then this one is the, gotta do this graph right here, so I am going to clear this out. Don't save. And I'm just going to type this in right here. 2 to the xx plus 1 minus 1. 2 to the x plus 1. 2 caret x plus 1 minus 1. What's my k value? It's negative 1 right here. So I'm going to type in y equals 1, negative 1. And the blue is the horizontal asymptote, the k value right there. All right. The domain is all real numbers, like I said. Domain is all real numbers. You either know it or you don't. You got to memorize it. All right. The range is from the horizontal asymptote, since it's going up. It's from the horizontal asymptote to positive infinity. Horizontal asymptote is negative 1 right here. So negative 1 to positive infinity. It can't ever touch the negative 1, so it's got to be this parenthesis, not a bracket, parenthesis. And then the horizontal asymptote is the negative 1. It is this value right there. Alrighty, thank you.